Good day. We now move on to our second topic in grade 11 probability, which is Venn diagrams. During the first 3 lessons, we discussed the rules of probability. In the next 2 lessons, we will focus on Venn diagrams. First of all, we're going to look at 2 event Venn diagrams. So let's look at the first example and see how we do these Venn diagrams. This problem says that 2 events A and B are such that the probability of A and B is 0.08. The probability of A and not B is 0.32. And the probability of B is equal to 0.2. The question is, we must represent this on a Venn diagram. So let's draw a Venn diagram and see what we're going to do. So there are 2 events. That's my sample space. And that is event A, event B. And whenever we represent information on a Venn diagram, we always start with the and part. This is and, that is where both events will take place. And we always want to start there. Once we've got this one, we will move to this and that one. So that is the A only and the B only, and then we look at what is outside the 2 events. Now, as you can see, and was given to us as 0.08. So we can write 0.08 right there where and is. So that and 0.08 right here. Now we must see if we can get this one, and what about that one? So let's look. You can see this one looks a little bit awkward. So let's come back to this one. But that one is quite clear. This is the probability of B. Now, when we talk about the probability of B, we refer to the whole thing. This is the probability of B. But as you can see, 0.08 is there already. So we can't put 0.2 here because then the probability of B will be 0.28. And it's clear that probability of B must be 0.2. So this plus this part must be 0.2. So that means this one will be 0.12 because we need to subtract the 0.08 from the 0.2 that was given to us. They didn't say anything about outside, so we still need to find that, but that we can do once we know this one. Now, of course, this one must have something to do with this given one. And this one say the probability of A and not B is 0.32. So where will we find this part in the Venn diagram? Which part in this Venn diagram will represent the probability of A and not B? So I'm just going to draw a Venn diagram here on the side. It's got nothing to do with the one we are busy with. It is just to quickly explain what this is all about. Now, when we look at the probability of A, you will agree with me, it represents the whole of A. So that is not too difficult. When we look at not B, this part is B, so what is not B? Not B is everything except this that I indicate here. So that means that not B will be this one as well as outside. So I'm going to use little ticks to indicate this. So the probability of A will be here and there. And then that not B, I'm not supposed to use B, I'm supposed to use not B, which is this and outside. So I'm going to use little ticks to indicate it. Now, as you can see, by using these little ticks, it's quite easy now to see between these two events, A and not B, those two events, that this will be the and part, because that is where the two ticks are. So that means that is the both part. And that is where that must go. So that 0.32 is this part. So in our Venn diagram, it will be this one, 0.32. We're not going to subtract the 0.08 because that part is only this one. So we can put that 0.32 right here. So there we have the probability of A only, probability of the and probability of B only. The last thing that we need to find is what is outside. And that is easy to do because we're just going to subtract the sum of these three from 1. Always the probability of the sample space is always 1. So remember that. So now to find what must be outside, we will say 1 minus the sum of those three that we've got on our diagram already, and we will add the 3 and we will subtract it from 1, and it's not a difficult calculation, and you will agree with me, it's 0.48. So outside is 0.48. To make sure that you are correct, you may take this plus this plus that plus this one, and those four must equal 1. And when you do it, you will see it's equal to 1. So that means our Venn diagram is now complete. So we are now ready to answer the questions based on this Venn diagram. So let's just go to the next screen and you will see the questions. The first question is to find the probability of A or B. Now, when we want probability of A or B, you will remember it is everything inside represents your or. Remember, this represents and, that represents or. So to find or, we can just add this one plus that. And that is what we did here already to when we calculated that 0.48. And you will now agree that the probability of A or B will be equal to 0.52 because that is the sum of those three parts inside. If I just go back, this is now where we take this plus that, and that will give you that 0.52. So it's once you've got the Venn diagram, it's quite easy to answer these questions. So we've got the probability of A or B. The next question asks us for the probability of not A and not B. Now that is similar to the one we just spoke about earlier. And I just want to show you, before we do it, I just want to show you on a Venn diagram how I will find the probability of not A and not B. I'm going to use little ticks again. Not A is everything except A. So this is my A and that is B. So everything except A is this one and outside. Everyone except B is this and outside. And now they ask us for and means the two ticks. That is where and is. So what they ask us to find here, this probability, is the outside, is the 0.48. And I hope by using these little ticks you can see it's not too difficult to find it. So this probability of not A and not B is equal to 0.48. And just so that you see again, that 0.48 is this one, because that is what they ask us in that question, that probability of not A and not B. In the last part of this question, they ask us if the two events are independent or not. And they also say we must motivate. So it's important to take note that you not only supposed to say yes or no, but you also need to motivate your answer. So to do this, we're going to look at the rule when it comes to independent events. And that we refer to it as the product rule. That rule says that the probability of A and B, that is the left-hand side, and the right-hand side of that rule says the probability of A times the probability of B. So we need to see if this rule is true, because they want us to determine if the two events are independent or not. So we can't say this is equal to that, because then by implication we are saying they are independent. We first need to calculate or use our Venn diagram to find the and, which will be easy because we've got the Venn diagram. And then we need to find probability of A, which is also easy, and we need to multiply it by the probability of B. And if the two answers, left and right hand side, are the same, it means they are independent. If they're not the same, they are not independent. So what is the probability of A and B? So we look at the and you can clearly see that is 0.08. That is the probability of A and B. So when I go back here, I can say that is 0.08, and that is my left-hand side. Now I'm going to move to the right-hand side, and I want the probability of A as well as the probability of B. So let's now do that. Probability of A is those two. So we must add those two to get the probability of A. And the probability of B, those two. But you hopefully still remember that probability of B was given to us as 0.2. But when I add those two, I get 0.2. When we add these two, 0.32 plus 0.8 or 0.8, then we get 0.4. So let's now go back to this right-hand side. So the probability of A, we said it's 0.4, and we multiply with the probability of B, which is 0.2 from the Venn diagram. And when we multiply this, you can see we get 0.08. So what do you notice? That the left-hand side is equal to the right-hand side. And what does that mean? That events A and B will be independent. And with that, we answered the question that they will be independent, and we also motivated that answer. Let's now move to the next problem. This problem says two independent events A and B are such that the probability of A is 0.6 and the probability of B is 0.4. And they ask us to find the probability of not A or B. So probability of A was given to you, probability of B was given to you, and they ask us for this. Now, the moment they want us to find one of these probabilities where there's a not with A, or there's a not with B, or sometimes a not with both, like in the previous question, we make use of a Venn diagram. So I would just like to start off by drawing the Venn diagram, and we can see where we will find that probability of not A or B. This is my sample space, and this is event A, this is event B. We always want to start with and, But as you can see, and was not given to us, but it's given to us that the two events are independent. Now, the moment that we know they're independent, we know that then that the probability of A and B is equal to the probability of A times the probability of B. So that means we can find the AND because we know what probability of A is and we know the probability of B, and we know that they are independent, and that is why we are allowed to use this rule. So let us just substitute now the probability of A, which is 0.6. We multiply the probability of B, 0.4, and that will give you 0.24. And that is the AND. So this 0.24, that is the and that goes right there. So let's put it on our diagram, 0.24. So now we need to find this part as well as this one, and then also what is outside. So let's go for this A only. Now we know the probability of A, which is 0.6. So this whole thing must add up to 0.6, but we've got 0.24 already. So you agree that this part will be 0.36 because they add up to 0.6. To find this part of B, we look at the probability of B, which is 0.4. We have 0.24 already. So we say 0.4, subtract the 0.24, and that will leave us with 0.16. So now we've got all three of these, 0.36, plus this, plus that. And we need to add those three, subtract it from 1, so that we get what is outside. So if I just write it down, I will say 1 minus 0.36 plus 0.24 plus 0.16. And you hopefully will have the answer as well as 0.24. So that is the answer for the outside. So we will put down 0.24 outside there. If you want to check your answer, if it's correct, you will take this, plus that one, and that must give you 1, which in this case is true. So now it's time for us to look at the question. The question is the probability of not A or B. So to answer this, we're going to use our Venn diagram to do it, but we first need to find out where this OR will be. So I'm going to use little ticks again to do it. So I'm going to say where is not A. Those two represents A, so not A is this part and outside. So I'm going to put a tick here and a tick outside. Now I'm looking at B, because that's the other event. Remember, the two events are now not A and B. And B is easy to find. And I'm going to tick B is this one and that one. Now, when you look at this Venn diagram now, the two ticks, that represents AND. And when we add everyone who's got a tick, that gives you OR. Just take note, because of the two ticks, we're not going to add 0.16 twice. We only say this, plus that, and that will give us this, the answer to this question. So we're going to say 0.24 plus 0.16 plus 0.24, and our answer then will be 0.64 when we add those three. And that is the probability of not A or B. I believe after these discussions, you are comfortable with two event Venn diagrams. Thank you.